Aktau port, situated on the eastern coast of the Caspian Sea, is the only seaport of the Republic of Kazakhstan aimed for international shipping of different dry cargoes, crude oil and oil products. The port has been expanded as part of the international Trans-Caspian corridor in order to double its capacity and to transship approximately 3 million tons of dry cargo per year. A major component of the expansion is the dredging of the harbour basin to the required design level of -34 meters Baltic datum, equivalent to -6 meters mean sea level. SemArco has signed the contract with national company Aktau International Trade Seaport and executed the dredging works of 890,000 cubic meters in the record time of 6 months. Based on the contract requirements and the navigational river canal limitations, we have deployed our medium-size and shallow draft cutter suction dredger Aitos, along with a booster station, a multicat, a stand tug, a survey boat, floating pipelines, floaters and all necessary accessories. A huge operation of mobilization, including all kinds of formalities, customs and reflagging, has been executed in a very short period of time. The dredging equipment were mobilized from our company's facilities in the Red Sea, Saudi Arabia to the Caspian Sea. The dredging spread arrived on a submersible vessel from Jeddah, Saudi Arabia to Kavkaz, and consequently was towed by river tugs via the Volga-Don Canal to Aktau. On the stockpiling area, dry earth-moving equipment such as excavators and loaders were used for controlling the filling works and spreading off the dredged material. The dredging and stockpiling operations were executed in one continuous, uninterrupted dredging operation of 24 hours a day, 7 days a week. The allocated local and foreign crew, totaling more than 100 people, worked in 2 shifts of 12 hours per each shift in a rotation scheme, according to the Republic of Kazakhstan labor law and regulations. The efficient staff and crew, from the project manager to the engineers, vessel operators, mechanics and seamen, ensured the smooth operations for safe and timely completion of the project. Pre-construction surveys, interim surveys and post-dredge surveys were carried out to verify the precise execution of the works. The latest GPS technology, with the support of an echo sounder for depth measurement, were used to position the equipment and monitor the dredging levels, achieving accuracy of a centimeter. The hydrographic surveys were plotted on charts used for weekly or monthly reports, checking the final configuration of the seabed. Finally, all the obtained data from the post-surveys is incorporated in the as-built drawings, which is the basis for calculating the final quantities and future references of the area. The cutter suction dredger is a stationary dredger equipped with a rotating cutter head and centrifugal pumps. The cutter head, situated at the front of the ladder, excavates the material by a rotating action. The dredged material, a mixture of soil and water, is pumped hydraulically via a system of discharge pipeline network to the designated enclosed stockpile area. The control of the dredging process of a CSD is done by means of the dredging computer and the positioning system, which is a real-time kinematic differential global positioning system for the horizontal control of the dredger. The cutter head position is calculated by the dredger's computer and displayed on the screen in the operator's room, while the depth information is displayed by means of cross-sections or layer thickness, hence enabling the operator to carry out the job with the required accuracy. Prior to the commencement of dredging operations, all obstructions identified during the pre-survey within the dredging area were removed from the seabed with the use of the multicat and were properly disposed of. In the stockpiling area, prior to any filling operations, initial containment bunds were constructed utilizing imported quarry material or available suitable in situ material. The bunds helped contain the dredged material supplied from the dredger. All outcoming dredged material was directly pumped via the discharge pipeline to the dedicated stockpile area, located on shore approximately 2.5 kilometers away from the dredging area. Due to the long pumping distance between dredging and stockpile area, the floating booster station, Aegis, was connected to the discharge pipeline in order to maintain high rates of productivity. During the dredging and stockpiling operations, excavators were spreading the dredged material, while more excavators and loaders were used for the pipeline extensions. In an appropriate location adjacent to the filling areas, a settling basin has been constructed to allow the suspended sediments to further settle down before the process water leaves the filling areas, hence allowing minimum amount of fine material returning to the sea. Different techniques control the speed and the volume of process water flowing back into the sea. At the exit of the settling basin, where the process water leaves the filling areas, a dewatering pump of sufficient capacity, equivalent to the capacity of dredger's pump, was installed. SemArco's HSE policy is implemented in the execution of the project and comply fully with the health, safety and environmental requirements. The significant health and safety hazards, in addition to the environmental impacts of the work, have been identified and analysed in accordance with the General Procedure, Hazard Analysis and Environmental Impact Assessment. When dredging works come to an end, as proven by the post-dredged surveys, demobilisation of the dredger and other auxiliary equipment commence, and the site is cleaned of all temporary works. Final quantity is calculated as built drawings are submitted to the client and the site is cleared of all our equipment. It is our company's policy and objective to deliver quality services to our clients in the most efficient manner and in accordance with the most demanding contract requirements. Upon contract award and prior to commencement of the works, a site-specific project quality plan is prepared and is the basis for all planned operations. It is completed with general quality procedures and, if applicable, with the site-specific procedures and instructions.